Okay, I see a red light, which I think means that we're recording. So let's go ahead and get started. Welcome to CSE 143. I'm in an empty room, lots of seats in front of me that almost all have these X's on them, which is a little bit odd to see. But welcome to spring quarter at the University of Washington. I'm going to be saying a little bit about the course today, and then I'm going to start with some material. So, as I mentioned in the email that I sent out yesterday, the approach that I prefer is kind of making these videos early in the day on Monday and Wednesday and Friday. I use lots of the different features available to me, and it's a way of making a high-quality video. What I did last quarter for 142 is, which I'm going to repeat again this quarter, is that I will be available during the 2 lecture times to answer questions. It was interesting, in the first week of the 142 class, I was almost overwhelmed with questions. I was getting, something like 10 pages worth of questions being asked in the early lectures for 142, which was actually a nice problem to have. It meant that people were not shy about asking questions. By the end of the quarter, I was getting 2 or 3 questions total. So I think that people were not watching the lecture, at least during the regular lecture time. Let me just make a pitch for it. I think it's extremely important to watch the lectures. I've heard people talking about courses like 142 and 143. What does it take to succeed? Some people think that the courses are geared towards people with prior programming experience. There's some truth to that, and that, prior experience can be helpful. But I think that we go out of our way to try to make the course something that will work well for students who do what we ask them to do. So watching the lectures is one of the most basic things that you can do. Woody Allen made a joke that success is showing up is 80% of success, I think was the way he put the joke. So I actually made some statistics that many of you were in the winter 142, so you might find this interesting. I looked at how much of the lectures students had watched, how many students there were in each of these different categories. Large number of students who watched less than 60% of the lectures, and the average grade. So the 155 students who watched 90% or more of the lectures had an average grade of 3.55. So, I think it matters a lot to participate. There's a lot of stuff that I talk about in lecture that's helpful for the homeworks. Helpful hints about grading. We are very picky about style grading, but we also give you a lot of information about style grading in lecture and in section and on the class webpage. So all of these things are things that it's important to be participating. So I'm going to do this again this quarter. I'm going to be doing there'll be a question and answer link available. I've been using a shared Google Doc. It's a little dangerous, but seems to be working out fine. When you guys connect to that shared Google Doc, I don't know who you are, so it's anonymous when you're asking these questions. So let's hope we can have good participation this quarter with people watching the lecture during their regular lecture time. And asking questions. Now, I know some of you are in a different time zone or something, so not everybody's going to do this. For some of you, it's going to be more convenient to watch it at another time, and that's fine as well. So, doing it this way gives you more flexibility than you would have otherwise. Well, let me spend a little time. The class webpage. Actually, let me get to that in a second. What I wanted to do was to spend a little bit of time just kind of giving you a bit of an overview of some of the things we're going to be talking about in the 143 class. And I'm going to begin by mentioning what we did in the 142 class, just kind of a reminder of things that we had covered there. So one of the main topics in 142 is what we would call control structures. You can't write code unless you can do various things like sequential access. It's just the simplest form of access, where you have a statement followed by a statement followed by a statement. You execute things in sequence. We had conditional execution with if-else. We had loops available to us. We saw how to put things into methods. That involved understanding parameters and returns. So there was a whole lot of material that we covered that was basically just control structure type material, just basic things that you need to be able to do in a programming language. Another thing that we did is we discussed various I/O input-output facilities. So we talked about console input early in the quarter, and we also did file processing. Was another form of input-output that we studied there. And in terms of data, we began the course by talking about the primitive types. So remember, the primitive types are things like int and double. The ones that start with a lowercase letter are all of the primitive types in Java. We saw that they behave in a certain way. They have what we call value semantics associated with them. But we also looked at strings, we looked at arrays, we looked at classes, and some built-in objects that we used for various things. So strings we used a lot. I mean, strings are a very central part of Java, so you tend to use strings quite a bit. Arrays was chapter 7, and classes was chapter 8, and that's kind of how we ended the 142 class. Was the last two big topics were arrays and classes. My sense is that people don't quite master it, particularly the classes part. There's a lot of concepts there, and it takes a while for some of those concepts really to sink in. So my assumption is that you're still a bit rusty when it comes to arrays and classes, and that's why the 143 class kind of begins by reviewing arrays and classes. We're going to be looking at sample programs and doing a sample assignment that's going to involve, in effect, an review of arrays and classes. So that's kind of the 142 course. I would say 142 is very detail-oriented, just lots of stuff to cover because, if you don't have any programming, then there's a lot of different aspects of programming to cover. Once you get to the 143 class, though, there aren't that many details left in terms of the language itself. In terms of control structures, the one thing that we add in the 143 class that we didn't do in 142 is something known as recursion. It's not a complicated idea, recursion, but it takes a while to get used to using recursion well. So we spend actually a lot of time talking about recursion in the 143 course. And we have more time to talk about data structures. So, there's the review of arrays and classes, but then we talk about other kinds of structures. Two important structures we're going to discuss are what are known as linked lists and binary trees. Those are two structures that are important in programming and computer science. And actually, an interesting thing is between these three topics, recursion, linked lists, and binary trees, that is 5 of our 8 programming assignments. So you could think of it as 5/8 of the course, just those 3 topics, recursion, linked lists, and binary trees. We're also going to be looking at what are sometimes called the Java collections classes. Java has an extensive library of built-in structures that are available for programmers to use. And we spend a fair amount of time in the 143 class talking about these built-in structures. It's a very practical thing for you to learn in Java, and using the structures allows us to solve some interesting programming problems. So that's kind of another big aspect of the course. I know that many of you will have taken 142 from me last quarter, so some of what I say about objects and various other things will be review, but I don't want to assume that people have taken my version of the 142 class, so I always try to review the important things that we need to. One of the things that I emphasized a lot at the end of my 142 last quarter was the idea of 2 views of an object. When we started talking about classes and objects, and we talked about this, I mentioned this fellow Arthur Reel, who wrote a book on object-oriented design heuristics in C++. I have a link to his design heuristics on the class webpage in case you're interested. Real had suggested that one of the ways to get people to think about this is that, if you have a room full of people, which we don't have, but I can pretend, if you had a room full of people, you can say, well, think about a device like a radio. And so you ask the audience, raise your hand if you think that you would be able to use a radio if I gave one to you, put one in front of you. And most of the people in the class raise their hand. Well, raise your hand if you think you could build a radio from low-level components, and a few electrical engineers, will keep their hands up, but not that many people will have their hand up for that second question. So these are kind of these two different views of an object. So there's an external view of an object, also known as the client view. Someone who is a client, a user of a structure. And basically what a client is interested in knowing about an object is what it does. So a radio, you'd want to know that we can turn it on, we can set its volume, we can change it to different stations. We're going to talk about some of the technical terms associated with this state and behavior, but we'll do that more starting in the next lecture. But so there's kind of this idea of we all know how to use a radio. We all know how to be a client of a radio. We all know how to be on the outside of a radio and turn the dials and flip the switches and so forth and get it to do what we want it to do. But then there's an internal view of the object, which is the implementation view, which is how it does it. So that's a different understanding of an object. It's kind of prying open an object and seeing what's inside and how the pieces are put together in order to allow it to do what it is that it does. So I mentioned this idea at the end of 142. It's a major topic in the 143 class, and it's going to become part of our grading as well. So we're going to want you to be thinking about this, and we see students struggle with this concept. It takes a while to really be able to recognize the difference between client detail, a client view of an object versus low-level implementation details. So we'll spend a lot of time talking about it. Your TAs will spend a lot of time talking about it. But that's going to be a major topic. And I can mention that for linked lists and binary trees, we are going to be implementors of those data structures. So we're going to use that for implementation. But when it comes to the Java collections classes, these are these off-the-shelf built-in structures that are in the Java libraries. We're going to be a client. And the 143 class, I think, can be a little bit annoying in that we almost switch week by week, that there'll be a week where we're implementing a data structure, and then the next week we might be a client of a data structure. So there's going to be this switching back and forth. It's a little bit disconcerting, but we'll try to be pointing out to you the distinction when we can. Something that I do in the 143 class is that I want to do kind of a major case study that I do throughout the quarter. There's a structure in Java known as ArrayList of E, and most of the 142 classes, including mine, we do a little bit with ArrayList of E at the end of the quarter. It's probably the most commonly used data structure in Java, the ArrayList of E. I would like to kind of talk about ArrayList of E, but the of E part, there's kind of this less than, greater than with the E, makes it somewhat complicated to understand what's going on with the structure. So what I like to do instead is I do what's known as ArrayIntlist. So that's, so basically what I'm going to do is instead of writing a generic structure where you can have any kind of element type, I'm just going to choose that we're working with simple ints. So that simplifies the of E part, and it allows us to focus on the other parts of it, which is kind of how these structures, how this structure is implemented, the ArrayIntlist. And sometimes people will say to me, is ArrayIntlist a really useful structure? And the answer generally is no. There aren't tons of people out there who are clamoring for an ArrayIntlist structure that would be available to them. But it's a good structure to study. So, I mean, really, we're doing it as a way of understanding ArrayList of E. And before the quarter is over, I'm going to show you an example where we take one of these int-based structures and we turn it into an of-e structure. So you're going to see how that's done. And actually, it's really quick. It really doesn't take that much time. So we're not sacrificing much by having it be an ArrayIntlist. And it simplifies things so that we don't have to focus on the issue of types. We can focus on the structure itself and how it works. So that's another part of the course, is that we're going to talk a lot about the ArrayIntlist class, and we're going to be using it as an example to understand. In these first 2 weeks, I'm going to spend a fair amount of time talking about ArrayIntlist. When I release your first programming assignment, it's basically, you're going to be looking at an ArrayIntlist implementation as the guide for how to do this somewhat similar thing that I'm going to have you do for the programming assignment. All right, normally I'd ask if there's questions. Maybe you guys will use the Q&A form and ask questions there, but that's kind of the broad overview of the course. Let me mention a few things from the class webpage. You're probably already there. I don't know how you would have gotten the link to the lecture otherwise, but in case you aren't, this is a short version of the URL that gets there very quickly. So Canvas we use for storing scores, but we don't use Canvas very much in this course. Don't send me email through Canvas. If you want to send me email, send it to my UW account that's listed on the syllabus. So the course webpage, there's tons of resources that are going to be there. I'm going to say a few things today, and I'll say more as we go forward about what's going to be on this course webpage. I guess I didn't introduce myself. Maybe people may know things about me. This is my 18th year at the University of Washington, my 17th year at the University of Washington. It's been a long time. I've been teaching for 35 years. I taught first at Stanford and then at the University of Arizona. And I came here in 2004 because the computer science department was interested in redesigning their intro courses. And I had done that at both Stanford and Arizona. So I designed 142, 143. I wrote the textbook with my co-author, Marty Stepp. If you dislike 143, to the extent you dislike 143, you can blame me for it. The course webpage is going to have various things posted here. Let me point out a couple of these things today. So there's a calendar link here. Those of you who took my 142 know that what I do later in the day after the lecture time, I post various resources here. So I've already posted for today's lecture a kind of a great big slide deck. You could think of it as, the best of CSE 142 slides. So if you haven't taken 142 from us, or if it's been a while since you took 142, you might want to kind of look through this slide deck as a review of the things that were included in our 142 course. So I've already put that link up. In 142, I included links to lecture slides because my co-author had done PowerPoint slides for the lectures. I don't do that in 143. There weren't slides available at the time. He later did slides, but I actually did something that I think is more useful, which is that I have written up my 143 lectures. So what I do is I have detailed notes. I mean, what happens in a lecture like this, any of you who had me for 142 know that my style is that I do a lot of live coding. So we'll go into JGrasp, I'll be writing code, and we'll say, well, we wrote this version, and we noticed there was this error, so we fixed it to do this, and then we noticed there was still another error, so we fixed it by adding this. So it's very dynamic, it goes really quickly. I know some students try to keep up with me by doing the same things on their own computer. I think that's hard to do, so I don't really recommend it. I mean, if it works for you, that's great, but I think that things go fast enough that it can be hard to do. But what I do then, and taking notes is even worse, to try to write down everything is I think, complicated. So that's why the lecture notes that I have, I think, are particularly helpful, because I include all of those different versions. First we looked at this version, then we changed it to this, then we changed it to this, then we changed it to this. So there will be lecture notes available. They have all of the different stages that we go through for a program like that. All of the complete programs that we come up with, I will post on the calendar for today, along with a link to the lecture and a link to the questions that were asked. So later today, this little cell is going to have a lot of extra stuff in it that are the resources for this particular lecture. I include kind of the reading listed here. The reading is telling you the relevant sections in the book for what I'm covering there in the lecture. It's kind of up to each of you to figure out how much you would want to do reading. Some people read before the lecture. Some people read the material after the lecture. I think that so what other people do is they just kind of try to pay attention to the lecture, and if the lecture made sense, then maybe they don't need to do the reading. But particularly when, if the lecture is confusing, it went too fast, there were details you didn't get, that's when the reading is most helpful, because it's usually more detailed. Obviously, it goes more slowly. So the reading is something that you're going to figure out what works best for you in terms of when you would do it. I'm not necessarily, I give the lecture as if you haven't read it at all. So you can kind of come to the lecture if you want to, listen, see how it goes, and potentially look at the material after the lecture. But there are often things that are in the reading that I don't feel the need to cover every single detail. So it can be useful to even just skim the portion of the book just to see if there was something in there that you might want to pay attention to. So calendar will be very useful. Lots of stuff is going to be posted there. On Wednesday, I'm going to release the homework, so I'll tell you about that. Then there's a link here that says Java software. That will tell you how you can get the same programming environment on your computer that you're going to see me using on my computer. So you need the Java compiler, JDK. And you need to have some kind of an IDE, an interactive development environment. I use an environment known as JGrasp. You can use whatever you want, but JGrasp has a lot of nice features to it, and so I would recommend it. Course staff isn't set up yet, but that'll be set up later today. This Zoom links tab, so this goes to a page that requires you to log in with your UW-Net ID. We don't want to make all of our Zoom links available to everybody in the world, so that's a little bit of protection there. What you'll find there right now, the only thing you'll find right now is a Zoom link for my office hours. I have office hours Tuesdays 1 to 3. Be happy to see any of you tomorrow who want to ask me questions or talk to me about various issues. Later tonight, so we're going to have a staff meeting later today, and I'm going to post later tonight links for the discussion sections. So we have discussion sections on Tuesday and Thursday, and we're beginning tomorrow. So be on the lookout for that. I will post it later today. I will update the Zoom links page so that it has the great big table of the different links for the discussion sections. And I'll send out an announcement email once that becomes available. So Zoom links, that's where you'll go to be able to go to your discussion section. Later, I'm going to put up links for TA office hours if you need to get some help from TAs. Link to the message board. We're using an Ed message board. You can ask questions there if you're interested. Various other kinds of links that are here. The syllabus is important. I'm not going to cover everything about the syllabus, but I'll mention a few things. Overview mentioned here. The discussion section was listed here. In 142, we gave a participation score for section. In 143, I would say you would be crazy not to attend discussion section. And it's so, in a way, it's so important that I don't want to add the extra burden of keeping track of who's going. So I highly recommend that you go. I assume that students are participating, but we don't take attendance in the discussion section. Grading, it mentions here that we're not doing proctored exams, but we're doing something that we did last quarter in the 142 class, which is that at the normal midterm time, I will ask you to complete a midterm. At the end of the quarter, I'll ask you to complete a final. It's not going to be proctored, so we're not trying to look to control for cheating and things like that. we'll ask you to upload your exam and spend 15 minutes discussing it with your TA. And if you do that, if you take the exam and have the discussion with your TA, you'll get full credit. So we're not grading, you're not going to get an 82 out of 100 or something on exams. We're doing it because I think it's important to have that aspect of the course, even though we're not in a position to do proctored exams. There's a mention here of how these things get turned into grades. Any registration issues, this is the email address to use to email about registration issues. Late policy, you all have 10 free days of lateness. It mentions here that you can't turn in a homework more than 4 days late. This was a problem last quarter. Many students didn't meet this cutoff and then were hoping that they could get an extension. We almost never give you an extension beyond the 4 days. So it really is a hard cutoff. You need to pay attention to that. Some people say I was only a half an hour late. Doesn't matter. We expect you to turn it in by that absolute cutoff. And if you say to me I was sick or something, you need to talk to me before the cutoff if you're sick. I mentioned that here. Talk to me early. Send me electronic mail. It's here. My email address is up here. Send me email if you are having a problem that would require you to have an extension. I'm open to the idea of an extension when you contact me early, not generally open to it when you contact me after the fact. Policy and collaboration, there's a lot of misconduct cases that we're having. Mostly people are looking up solutions on the web and including things in their code that are obviously from a public solution. If you can find it, we can find it. There was a lot of this last quarter in 142. My hope would be that we have less of it in 143, but it's quite possible that the people that this is relevant for aren't even watching this lecture. So in any event, I would love to see a reduction in the misconduct cases that we've had. We do a pretty good job of spotting it when you are either having a friend help you out in a way that's inappropriate or going to a source on the web for your answer. We have lots of TA office hours available. You can discuss all sorts of things. I would give you lots of sample programs, lecture notes, there's course videos. There's all sorts of stuff that you can discuss. You can go to the discussion section and be very interactive, talk to students about problems that we assign you and so forth. So that all of those aspects of the course, you can be very open and collaborative and talking a lot. But for the homework, you should be doing that on your own. If you have some kind of a tutor or someone working with you, don't have them help you with the homework. That's something you should be doing on your own. Otherwise, it tends to lead to you having a solution that looks a lot like another student's solution or a public solution from the web. So my hope is that we could see kind of a reduction of the misconduct. All right, let me switch to JGrass because there are some things I want to do today. I want to kind of do a first version of this ArrayIntlist class. As I said, we're going to be talking about it quite a bit in these first 2 weeks. I wanted to begin by showing you a little bit of ArrayList code. This is some code that I do in the 142 class with students. It kind of shows you a translation. If you know array style operations, it shows you the ArrayList equivalents. We're going to talk about ArrayList a little more also in Friday's lecture. I wanted to do just a little bit of intro to it here. I wanted to do a kind of a debug here. So I can go ahead and execute this line of code that constructs an array list that stores strings. And JGrass has nice data structure viewers. So I kind of drag this thing out from my little debugging window here. And there are various viewers I can use here. I want to use what's known as the presentation viewer. So it's kind of trying to show me the equivalent of an empty list. So that's what that little dashed box is supposed to indicate. So the ArrayList class has an add method where you can say append something at the end of the list. So this is appending the string 4 at the end of the list. And I'm using this little command right here. This is the JGrass debugger that lets me step one step at a time. So I'm going to say execute that line of code, and it added 4 here. There's other kinds of viewer settings that you can do here, like you can make that string a little wider, you can make that text a little bigger, or maybe that's probably a good size for it. So this has got a series of appending commands, 4 7 years, etc. So I can kind of do 4 7 years, what was next, ago. So I screwed up on purpose in setting up this little sequence here that we didn't really want to have this right here, and I forgot a word. So it's to show you there's a variation here. There's an add command that takes an index. This is going to add at index 2 the word and then it's removing at index 5. You'd think that's going to remove the word ago, but that's not what it's going to do, because when it adds at index 2, well, let's go ahead and do that. It adds at index 2 the word and that scooched everything over. And that's why that screwy string that I don't really want to have is at index 5. Well, what I would say, the main point I wanted to make about this was just to be able to talk a little bit about the idea of internal versus external views of an object. So the client view, the external view, if we're kind of trying to understand how this structure works, I'd say this is a structure that grows and shrinks as I give commands like add and remove. So that's the way I, as a client from the outside, think of this structure. The question is kind of what's happening inside. If I pried it open, what would I see? Go ahead and let it do the remove command. It does a printing command where it prints out the contents. There's an index of that looks up and finds that the index of this word 7 is a 3. It prints that out. That's not what I wanted to show you. What I wanted to show you is I wanted to do a different viewer, and I want to go into show you what's known as the basic. So this is showing us the actual fields, the data. I've pried it open to see what data is inside, what we call the state information. And so there's something called mod count, something called element data, and something called size. I'm not going to talk about mod count, but if anyone wanted to know, come to my office hours or something, I'll explain it to you what it does. But there's something called element data. So what is making this work is that inside of it is an array, but notice that this array has got extra things in it. I'm going to show you that in an even nicer viewer in a second. And it's got a size of 6. Let me do, the viewer I want to use next is structure identifier. So this one is showing us that mod count and the size. It's not showing us the name here. That array is called element data, but we have kind of a nicer picture of the array. So notice that this array actually has 10 things, space for 10 things in it. And if we had looked at the very beginning, when this array list object was constructed, it was constructed with space for 10. So I kind of think of the array list as doing a kind of a magic trick. It's creating an illusion that this thing is growing and shrinking when it isn't actually growing and shrinking. What's going on is that there's an underlying array, this array that's 10 long, that's got space for 10 things, and the array is filling up slowly but surely. A little bit like, the analogy I use is it's a little bit like a motel that has 10 rooms. So, it can have 10 customers staying at the hotel. Initially, there's nobody at the hotel, and, you put your vacant sign on. Here we've got 6 customers who've shown up, and we put them into rooms. We still have vacancy. We still have 4 rooms available that we could rent out to people. So in thinking about an array list structure, and we're going to do the ArrayIntlist. So our ArrayIntlist is going to have the same aspect to it. There's kind of 2 different integers that you want to be thinking about. There's the capacity of this structure. How many total things could it store? And this one has a capacity of 10, but then there's also a size. How many of them are currently in use? How many of the rooms in the motel have customers in them? So this structure has a size of 6. We got 6 customers in rooms, but a capacity of 10. We have room for 4 more. There's going to be some issues of what happens when you run out of capacity. We'll talk about that in the later lectures. There's some very interesting issues and different strategies for what to do if you run out of capacity, but we'll talk about that later. The main idea here was to let you see that prying open ArrayList lets you find inside an array called element data and a size that keeps track of how many things are currently in that structure. So let me go ahead and I'll end this and we can collapse that back down. What I want to do next, let me go ahead and we'll see if this works. I want to do a little 2-column version of this. So, oops, let me try to grab this. Come on, JGrass, let me do this here. Let's stretch it over a little bit. So we've got something on this side over here, and let me do a new Java file that I'm going to put over here. So what I'm going to want to do is over here I'm going to make a public class called ArrayIntlist, and let's go ahead and do a save command. Java knows to save that as ArrayIntlist, so I'll go ahead and say save. This is the two views. You know, this is going to be the client view over here, and this is the implementation view over here. So for today's lecture, I think it's helpful to have both of them up at the same time. I won't generally do this, but you always want to kind of be thinking this way. There's the two different views. So over here, we're going to write code of a client who's going to use this structure. Over here, we're going to actually have the implementation details. So what was inside of that structure? We're going to have fields. That's the data that we put inside of an object. We're going to refer to that as storing the state of an object. This should be review, but as you know, we're going to do several of the examples of this in the coming lectures and the upcoming sections. But I want to have then two fields. Remember, there was an integer array called element data. Well, it was an object array in the other one, but for us it'll be an integer array. And we want to have an integer size. So that's what we have inside of the object, an array and its size. That's how we're going to keep track of things. Now over here, the comments say to make a list one, ArrayIntlist list one. So I'm going to say ArrayIntlist list one is a new ArrayIntlist, and I'm going to say ArrayIntlist list two is a new ArrayIntlist. So let's go ahead and let me compile this. Let me set a stop right here, and let me debug, and I'll scooch this over a little bit. So the first thing this does is it constructs list one. And so what it did here is it said make a new ArrayIntlist. I've used the analogy that this is like a blueprint, you know, for a building, a blueprint for a house, for example. And when you call new, you're saying, I want you to actually use the blueprint to make me an actual object. I want you to create an instance of this class. So the class is the blueprint. The instance, the objects are the things that are built using that blueprint. So we asked it to make a thing called list one. And if I open it up, I'll see that inside of list one, there's a thing called element data. It's set to null, which isn't good, but we'll fix that in a second. And it's got a size of 0. And if I stepped forward one, oops, I want to be over here. What happened? We were on this line of code. If I executed another line of code and we got list 2 here. Oh, let me go ahead and open up list 2, and it has an element data and a size as well. So, basically the fields describe what kinds of data to set up. Let me collapse this down for now. Now, how this element data was not set to be an actual array, so we kind of have to fix that. You could imagine that we would say something like equals a new integer array with a size here. We could do that, and it would actually work. But we're not going to want you to do that. One of the things that I did a lot in 142, and I'll do the same thing here, is I'm going to try to point out style issues to you as they come up. So one of the style issues that we're going to grade on is that we don't want you to be setting fields to things that are not their default value. We don't want you to do that outside of a constructor. So if you really wanted to do something like that, we would make a constructor, public ArrayIntlist. If any of this is unfamiliar to you, you need to be reviewing Chapter 8, where we talked about constructors and fields and all of this. But this is where I would say something like element data is a new integer array, say 100 long. Now, I don't need to set size here because I want size to be 0, and that's what Java will initialize size to be because it auto-initializes the fields to the 0 equivalent of the type. But it's not such a bad idea to kind of be explicit about what we want to do here. So now we're actually setting up an array and its size. This code here says to add the numbers 1, 82, and 97 to list 1, and then to add a 7 and a -8 to list 2. Well, so how would we do that? Well, list 1 has something called element data, and we could set the 0 element of the array to be this number 1. And we could say list 1 element data, element 1 would be set to be this number 82. And list 1.element data of index 2 we could set to be 97. So we certainly could do that. Would that get the object in a good state? I usually ask people, and someone will point out, no, it's not enough to put things into the array. Remember that there's a size. And if we've put 3 things into this object, we'd want to set its size in that way. Let's compile, I'll end the old debug. Let's compile and debug this one. So we'll let it set up list 1, which we will observe over here. So here's list 1 with its size of 0 and its array. I can scooch all the way over here. It's 100 long, so it's got indexes up to 99. And I can keep kind of just stepping through this code here. So it sets up a list 2, but I'm not using list 2 in this little sample code here. But it's going to set array element 0 to be a 1, so that a 1 should show up here. And then an 82 will appear in the next spot, and a 97 in the next spot, and then a size of 3. So I kind of manually set the array elements and the size of this structure with those commands that I wrote right there. Now, you certainly could do that, but that's not the way that we generally want to manipulate objects. That's kind of the client reaching in and manipulating these fields directly. So that's not the kind of code that we're going to want to write. I mean, we want to get the equivalent of that after we've added 3 things to the structure, but we want to do it by introducing a method. So I'm going to have an add method where I say append at the end of list 1. That's what the simple add command does. Add a 1, list1.add an 82, list1.add a 97. And then I'm supposed to add a 7 and a -8 to list 2. So list2.add a 7 and list2.add a -8. So we want to execute these various commands. That's going to require me to introduce a method over here. Public void add some value. So how are we going to do that? How do we do an add command? Well, where did the first thing go? Well, so what's size initially? Initially size is 0, and the very first number we want to add to the list goes into index 0. And then we would increase size to be 1. And then where does the next thing go? It goes at index 1. And we increase the size to be 2. Where does the next thing go? Index 2. So which element of element data are we manipulating each time? It's the element data that corresponds to the size. 0 initially, and then 1, and then 2. Well, this kind of makes sense when you think about zero-based indexing, that size is always 1 larger than where you last put something into the array. So, the array index size is kind of the right spot for where you would want to put this value. So we would come over here, and we would say element data of size is assigned to a value. And we'd have to be very careful. You have to remember to update size. So we would do that as well. Well, let's come back over here. Let me end this. Let me recompile. debug again, and we can go ahead and set up our list 1, set up our list 2. Now, here what I'm going to do is I'm going to choose a different debugging command I'm going to step into. So notice what it's showing us here is that we have two objects called list 1 and list 2. JGrasp uses this little notation where it gives numbers to the objects. So it's telling us that this is object 187 and this is object 188. Here we are talking to list 1. There's a term we used for that. The object that we are talking to is known as the implicit parameter. So right now, list 1 is the implicit parameter. It's the thing that I'm talking to. And if I step into, to go into the add command, I'm over here in this code right here, and you'll notice there's no list 1 or list 2 here. Well, that's because I'm inside of the object. I'm inside of list 1. Because list 1 is the object that I'm talking to. And notice that there's something here called this. That's a special keyword in Java that corresponds to the implicit parameter, the object I'm talking to, and it's object 187, which is what list 1 was. I can drag this out and kind of take a look, and I'll see the initial state of that object of list 1, where it's got a size of 0 and nothing in the array. Here, what it's doing is it's adding a 1, which goes at index 1, and then it's going to increment the size to be 1. And then if we kind of come back over to here, and if we step in again, now we're adding the 82, which is going to be, size is now 1, so it's going to add at index 1, the 82, and then we increment size to be 2. And then we come back, and if we step in a third time, we're adding the 97. Size is 2, so we add at index 2, and it increments size to be 3. So you'll notice that we've gotten to the same place we were before with the 3 values stored in our array and the size being 3, but we did it by making 3 calls on an add command. If I come back and step in again, so that was all manipulations on list 1, which is object 187. If I now step in again, I'm manipulating object 188, which is list 2. That's why this went back to being all zeros. And it adds the 7 to that list and sets its size to be 1, and then it adds the negative 8 to that. So that's a little bit of watching what's going on there. Let me end this. I got just a few minutes left. I want to mention just a couple of things. So let me do a system.out.println list 1 equals list 1, and system.out.println list 2 equals list 2. So suppose that I wanted to just kind of print out what's in these lists. So if I compile and run it, I get this screwy output here, ArrayIntlist with an @ sign, and then these various digits that those of you who took 142 from me know that I mentioned that this is a hexadecimal number, a base 16 number. Anyway, it's not what we wanted. What we want is to be able to see kind of the contents of this list. How do we do that? Remember in 142, we made a method called toString. Well, what I did is I made a toString method before class began, a little bit like Julia Child on her cooking show, that she would put something in the oven before the show began because she knew she wanted to pull it out at the end. Here's our cooked, cake or something like that. So I'm throwing in a toString because I knew that I was going to need that. I don't want to talk about the details of the toString because they're less interesting. But now that I've kind of included a toString, it's calling that method, and that's showing me the data in a nice form. I want to mention one last idea. As I said, we'll discuss this more in the lectures that are coming up and in section. So this is set up in a way where these fields, well, you saw me changing the fields here. I was changing element data. I was changing size. So one of the questions is that dangerous? Like, can I set size to be something that would cause a problem for the program? And the answer is yes. What if I set the size to be I could set the size to be 5,000, and now it's going to think that the array has got 5,000 things in it, and it's going to keep, going through all of these things, and it's going to get an array index out of bounds because it goes too high. or we could set it to something like a -8. You know, there's all sorts of problems that could come up by setting this size, you know, from the outside, letting the client set the size from the outside. So what we're going to want to do is to declare these to be private. Fields should be declared to be private